Okay, so we are now recording. All right, going back to the website. So when I do these recordings, I post them up to my YouTube channel. Y'all have all seen my YouTube channel already because that's where the pre-lectures are located. Notice this entry here, 216 pre-lecture recordings. When we get to the part of the course where there are no pre-lectures, in other words, when we get out of the flip portion and into the sort of more traditional portion, there is a separate link, a separate playlist there for the actual class meeting video recordings from that portion of the course. What we're recording right now will be put up there. And then there will be a whole lot of nothing for the first half of the semester while we are focused on the pre-lectures, and then I'll start putting, again, class meeting lectures there at that time. Okay, this Math 216 lecture materials. During my flipped portion of the course, I'll be referring to certain old exam questions. I'll be, going through and talking about them as examples and that kind of thing. So for your convenience, so you don't have to sort of jot down as we, go through, I'm just documenting here that, for example, from 15-16 spring, exam 1, question 3. That was one of the questions that we're going to talk about that day. Okay, I just want everybody to be able to refer to them. Also, there will be other days where we have questions that I'll put up on the board, and I'll do these. These are kind of a more active, sort of participatory exercise where, so it's called a think, pair, share. I'll put the question up on the screen, and then I will sort of tell everybody, okay, I want you all to think about this question on your own. Everybody think about it on your own. No discussing. Right? And then after about a minute or two, we'll switch over to the pair portion, and then I want everybody to pair up, discuss with your nearest neighbors. Right? But very importantly, everyone should, during the think portion, everyone should be thinking about it on your own. It's important that everybody give it a good old try. Pair is when you discuss your neighbors, and then after that, the share portion is where somebody who feels like they understand the question will volunteer to propose an answer. And then we'll have a little classroom discussion about it. Okay. All right. So anyway, these think, pair, share questions, so that you don't have to copy them down. They're in these same documents, these materials documents, and you'll notice that they're numbered by class lecture number. So, this one was for lecture number 13. Right. Okay. Okay. Link to the Sakai site. Y'all have all seen the Sakai site, I assume. Wait, have you? Yeah, surely you have. Let's see here. Other little things. I showed you the additional homework problems, tutoring. Y'all have probably seen my old exams and solutions, but if not, every exam, along with a full set of solutions that I've ever given in this course, are all posted in this same folder here. I encourage y'all to use these for study materials. I think the ideal is to look at an exam question first on your own. Give it a try, right? See what you can do with it. Write down your solution as if this is what you would put on a test, right? Having done that, then look at the solutions and then try to see, is what I did, how similar is that to what the solutions say? And did I really miss something? Did I get it wrong? Is my solution incomplete? Is my reasoning sufficient? That kind of thing. Okay. Right, a bunch of other little things I want you to read on the website. I will point while we're here to this recommendations concerning schedule. Each item listed here is something that I think ideally you should be doing every day. And I know that is a little overwhelming to look at. Some of these are real quickie little things. Just, be thinking about how the material that we're currently covering fits in with things that we did last week. Just, kind of keep an eye on the big picture sort of advices, right? But there are a lot of things that you should actively, be doing, set aside time for every day. And I wanted to have this up on the website to document what sort of the learning strategy is in this course. By the way, very much not the same as a high school math class. In high schools, I don't know my high school anyway. The strategy was come to class, we'll teach you, and then when you leave, you've learned. And that's it. right? And then, you got to do some homework, something, right? But we do not have anywhere near enough time to teach you all the material that you need to learn, all in this very confined, little small amount of time that I have contact with y'all, right? We get 150 minutes a week in here. That's it. It's surprisingly little time, actually. So the strategy for this course is, in some form or another, you should come to class meetings already having read something. For the flip portion of the course, already having viewed the videos. Then in class, we'll do what we can, right? I'm going to throw as many ideas at you as I can that I think are the most important. I will be picking and choosing. Again, I don't have time to do everything, right? So I will pick and choose what I think are the most important ideas, the best use of time that I think we can make of the class meetings that we have. And then after class, that's when another large amount of learning is supposed to be happening, right? You're not expected to digest everything that happens in class all during class. A lot of that digestion, a lot of that sort of internalizing and, wrapping your brain around it, however you want to say it, should be happening outside of class. And of course, you have to dedicate time for that to be possible. Okay, so anyway, during the flip portion of the course, here are some recommendations about how you should be spending your time to be taking a full approach to the course. And notice it's a lot of stuff, right? So make sure to read through this and think it through. I mean, how is your schedule going to factor in all of these suggestions? Now, of course, when we get to the traditional portion of the course, there's no more flip. That's going to change a little bit how you're going to use your time. And so here's just a sort of a parallel list of suggestions for how you should use your time in the traditional portion. Okay, so that's most of the website. I do want to point to a couple other things in this course information section of the website. You'll notice that there's 5 links up here at the top. All 5 of these pages are important for this course. General policies is various course policies. Do community standard. What kinds of collaboration are allowed on the homework? That's all addressed here on this page. Attendance policy, calculator policy, etc. Okay. Comments. This general comments page is really just a bunch of suggestions. Things you should know about what I think is appropriate in a college math class. Specifically in this college math class, and things you should think through, that kind of stuff. I mean, there's a comment in here somewhere about, make sure I can read your handwriting, right? So it's not exactly a policy, but it's something that you should think about. Okay. Let's see here. Exams, homeworks, and grading. There's some kind of broad brushstroke discussions about exams and about how grades will work, how you should interpret grades and that kind of thing. Make sure to read all of that. I will jump over here now to the 5th link. This is called Grading System for this course, Fall 2019. This is exactly how I will determine your course grade. We used to have a different system for block math classes, the different system, pros and cons. This new system here has some wonderful features. One is it's very simple. It's very easy to understand how your grade's going to be computed. It's also highly, I'm going to call it predictable. I'll comment on those after I describe the system for you here. Pretty much the point is, let's see here, let me go down to the percentages. Yeah, here we go. Here are the graded items for the course. 3 midterms, a final. You're going to have a homework grade, a quiz grade, and an attendance grade. Each one of these items, you will get a grade on the 4-point scale. 4.0 is an A, 3.7 is an A minus, the usual. Okay? I will average those numbers on the 4-point scale with these weights. That will give you a course score, I guess you might call it. And that course score will fall into one of these bins. So, for example, if you get a 3.07, that falls into this bin right here, and you get a B for the course. The idea is that these are the numbers for which B is the closest letter grade. So it's a really simple system. Everything's averaged on the 4-point scale, and pretty much, with a couple of minor exceptions, closest letter grade is yours. So very easy to understand, I think. Easily understood. Very transparent. Right? There's no mysteries happening behind closed doors as to, I'm going to combine all of your scores in, some way that's never disclosed, right? Nothing like that. Right? It's very, very transparent. And finally, what I mean by predictable, you can speculate fairly responsibly about what grade you're going to get in the course, knowing these weights. Right? So, for example, let's suppose that you're taking a diligent approach to the course. You're thinking about your homework, you're comparing answers with a friend, you're trading ideas, discussing, and you make sure that your homework grade is quite good. And maybe you do pretty well on the quizzes, and you're coming to class every day, no exceptions. Well, you can speculate, even though these grades won't be determined until later in the course, you can speculate that on this 15% you're going to have, maybe you say A- just to be cautious, right? Well, then once you know your midterm 1 and midterm 2 grades, between this 15% and that 15% and this 20% right there, you're already 50% to knowing what your course grade is. And then you could say, all right, well, look, as long as I get, such and such a grade on the final and such a grade on the third midterm, I can speculate pretty reasonably what my course grade is going to be. And that's a month before the semester's over. Everybody see what I'm talking about here? I think this is a useful tool for y'all to have. Of course, as you walk into the final exam, you'll already know all 3 midterm grades. Hopefully, by the final exam, I'll be able to tell you what your homework grades are, your quiz grades, and your attendance grades. I'll have all those numbers, I hope, tabulated by that time. And so you'll know 70% of your grade numerically. You can then immediately say, well, if I get this grade on the final, I get that grade in the course. This grade on the final, I get that grade in the course. It's just the numbers. Does anybody have any questions about the grading system? Anything like that? Everybody's good? Yeah? Mm-hmm.
I choose the 716.
Yes.
What's the difference between the 2 and 6?
Yes. So you're a graduate student, is that right?
Yes.
Yeah. Okay. So Duke has a relatively new rule in place that graduate students are not allowed to enroll in undergraduate courses. So 716 is a course that we created for graduate students. You're going to do 2 things. You're going to do all the work of this course. You're also going to do a separate curriculum that's at the graduate level that we'll talk about afterwards at some later time. But you'll do some additional graduate level work that's in addition to all of this here. So that's all. Yeah. So we have to have this separate course as listed as a separate item in Duke Hub because you're simply not allowed to register for 216. Yeah. Those of you in 216, you can completely ignore what we just talked about. Those of you who are in 716, at some point we'll have to have a conversation about that graduate component, and I'll be in touch in the next week or so. Yep.
So what's the maximum point that we're still looking at on one section? I think I was like points area, but I saw like the 4.05.
Yeah. So there's a this keep in mind. So this system here is just for my use, internal use within this course. So I'm free to count an A plus as a 4.3. Duke, for GPA purposes, uses A plus as 4.0, and I kind of feel like, why? Give me the extra point. I mean, come on. Yeah. But I'll count that as 4.3. So that's the highest grade that you can get on any graded item. Yeah. Got it. Anybody else? Yes.
When you return quizzes or test grades, will they have a score out of 100, or will they have a score out of the 4.3?
So kind of both. So you're going to get a score out of you're going to get some sort of a raw score. Maybe it's at 100 or who knows, whatever. And then I will also email to the class roster what I'll call a curve, namely, this range of raw scores gets this letter grade, this range of raw scores gets that letter grade, etc. So you'll get both pretty much at the same time. It's just that it's easier for me to communicate the scores through Sakai, and then the letter grades, by the way, I'll give you the curve and you can look up your own. Yeah. Yep. Anybody else? All right. So, moving along. Okay, so and then one last little document you've got to read here. This link, the fourth link in this list, proofs in Math 216. There's a little bit of rigor in this course. It's not like Math 221. In some sense, Math 221's one of its main purposes is to get students ready for a math major and ready to do the rigor that's going to be necessary in an undergraduate math major. That's not what this course is, right? That said, linear algebra is unavoidably a little abstract, and it's about connecting ideas. And really that's all a proof is a discussion of how these ideas naturally relate to those ideas in precise language. So unavoidably there's going to be at least a little bit of proofs in this class. So I want y'all to have a basic sort of working competence with what is a proof. We will work on how to write a proof as we go through the course a little bit. But it's not going to be the main focus. Anyway, make sure to read this page as well so you know what a proof actually is and what isn't a proof as well. So there's a bunch of discussion and examples and case in points discussed here. And you might amuse yourself to click on this link down at the bottom. It's a list of what he calls invalid proof techniques. And it's just for fun. It's silly. It's like, proof by intimidation, stuff like that. Yeah. So anyway, you might enjoy that. Okay. Back up to our outline. So that was the web page. Your first day reading assignment. Make sure to read all of the main page, every word that's on the main page, and then likewise every word on those links in the course information section that we just walked through. I want you all to make sure to read all of that stuff, familiarize yourself with all those rules and policies and etc. Click around with the other links. See what's out there. Make sure that you know kind of what you've got to work with. I can't say, read all of the content at every link and every link from every link. Pretty soon that makes the whole internet. But just see what you can get to, and I want you to know what's where for future possible use. Okay, let's talk about resources that you have to work with. Cheesy though it is, I like to list you yourself as your primary resource in this course. Now, so again, very cheesy. The reason that I put this up here is to draw focus to a big point of perspective, and that is that you have to take responsibility for being the engine of your performance in this class. Right? So, like I say, this is not going to be you come in, we talk, and then you leave having learned everything for the course. That's just not the strategy for this course. The strategy that we take in this course is I'm going to give you a bunch of materials to work with. One of those materials is come to class and I'll help you, right? But you've got to take your own initiative. So after class is over, you've got to go and do additional studying. I assume that when you walk out of my class, once we get around to talking about math, that is, I assume that when you walk out of the class, you will not understand everything that we just talked about. I certainly didn't when I was in college, right? We use class time I've got to get as much ideas as possible to you, and then you can go process it later. Right? This is one of the ways in which I think the YouTube channel is going to be a real big help, right? So I overload you with just a tremendous amount of stuff in class. You go home and your brain is kind of overflowing with, oh my gosh, that was a lot of math. What was all that? And then as you're trying to sort that out, you're going to find yourself thinking, wait, what did he say about okay, now I don't understand what he said about the such and such. Go back to the YouTube channel, right? Just pull that up. You can go right to that moment in the lecture and you can hear it again. What did I say about that? If you then don't understand it, then you can hit the pause button, look at some prerequisite material, think about what led up to that, ask some questions, try to try to get yourself more solid on what happened before that comment. Then rewind 30 seconds, hit the play button, and listen to it again. It might just make sense that time. Okay. So, studying the YouTube channel will help you understand the notes better. Studying the notes will help you understand the YouTube channel better. And so this is one of the big sort of picture strategies of, you go back and forth between the videos and the other materials that you have for the course, and sort of, bootstrap, stair step, whatever you want to call it, your way up to a better understanding. Okay, notice all that happens outside of class. Yeah.
Are the notes you use for the pre-lecture things on YouTube the same ones as the one you use in class?
Yeah, absolutely. I have one set of lecture notes. It's like 300 and some odd pages. I don't remember exactly. And yes, the same notes for the pre-lectures. That's the same notes that I'll be using if I'm doing examples in class, and it's the same notes that I'll be using during the traditional portion. Yep, totally. Anybody else? All right. So, again, you're in charge, right? So make sure to give yourself all the resources that you need. One of the big ones, of course, being time, right? Don't schedule yourself into too many things so that you just don't have the time that's necessary to be a good primary resource for yourself. Okay. All right. Let's see here. The book. Everybody's got quibbles about books. This book is pretty good. That said, there are certain things I don't like about it. There are a couple of things that I really don't like about it. I'll be commenting on those as we go through the course. But as a whole, overall, I like the book. I think it's pretty good. It's very appropriate for the course. And again, I have workarounds for the things I don't like. So I hope you'll take advantage of the book, spend plenty of time with it, read the examples, etc. My lecture notes, I like them, right? But anyway, they're going to give you a slightly different point of view on the ideas than the book does. And that's on purpose, right? So between the two of these, you've got a couple of, I think, good written references. I encourage you to read them both before you come to class. You might say in this flipped portion of the course, before you watch the videos, so that you'll kind of know what's going to happen as the material's being presented, so that you won't just go in, blank slate, no idea where the tricky curves might be, or where is this all going, what's the point, right? It's a good idea to have that all figured out beforehand. Likewise, read it again, both of them, after class. Right, so after you've watched the pre-lecture videos, after you've come in here and we've worked examples, that kind of thing, go through it all again. See if it doesn't make a little bit more sense the next time through. This after class is when you should be thinking in terms of, putting the final polish on your understanding of a particular topic. And again, you should not expect that final polish to happen during class. It's got to be after class. There's just too much to do during class. Okay. Lastly, another good reason to read these things is I will not be doing everything in class. There's not enough minutes. I only get 150 minutes a week. It's surprisingly fast. I know it doesn't seem like it, right? But compared to the amount of ideas that I've got to get across to y'all, right, it's a lot of stuff and not a lot of minutes. So there will be, I'll be making tough choices about, I want to talk about certain big picture points of view. I want to connect certain dots, draw certain arcs, certain key examples that everyone really needs to see. I'm out of time. Right? So I'll have to decide, again, there's tough decisions. What is really worth class time and what's, it's an example, it's in the book, it's very standard, y'all can read those, right? But nevertheless, I will be leaving some of that stuff for you to read. Some of it I won't even comment on. It just kind of won't come up in class. You're still responsible for it. Okay. Sometimes I will, though. Sometimes I'll specifically point out that, look, this little section of the notes, highly readable. I want you all to read that one on your own. Something like that. Okay, so notice, I've listed myself third in the list. Again, I think it's important to note the difference here. You're way up here as a resource. I'm way down here, right? So y'all are in charge. This isn't me teaching. This is y'all learning, right? It's both, but primarily this is your show. That said, I hope I can help. Obviously, I can't help if you don't come to class. So that said, do keep in mind attendance is part of your grade for the course. Likewise, the TAs. Now, everybody should be signed up for a section of Math 216D. In addition to this lecture, Math 216, the registrar views these as different courses. They are intended to be taken in parallel, and in fact, you cannot get credit for the course unless you're registered for both. Math 716 is different. The grad students in 716, I sent you an email talking about that. Okay, but the TAs hopefully will be a help as well. There should be plenty of time in discussion sections for just Q&A. Right, that's why they're there. This is the university's recognition of the fact that there's 115 people sitting here, and it's hard sometimes to raise your hand and ask a question, especially if you're concerned, oh gosh, is this a good question? I'm not sure if this is, I don't want to embarrass myself or whatever, right? So it is hard, fully granted. So the discussion sections are largely for, now everybody's got a small class environment with plenty of time, an hour a week, where you can ask questions, right? So take advantage of that. I would encourage you as you go through this course to just maintain a list of questions you'd like to ask in discussion section. Right? And then when it comes time, then you'll have your list, and there you go. Okay. Lastly, I am a big fan of study groups, working on homework together in groups. I think this is great. I did a lot of this when I was in college. So I did a second major in physics, and in those classes, I think that I probably learned more from my classmates, right, my study partners, while we were working on homework in parallel. Sometimes we would just have group discussions where we would just kind of open forum, just kind of trade ideas on, what do you think of this physics thing, or what do you think of that? Tell me how you understand the angular momentum operator, or something like that, right? So I think I probably learned more from my classmates than I did from my instructors, at least in some of my physics classes. So I think it's a wonderful resource. I hope you'll take advantage. I hope it goes without saying, well, I'm going to say it anyway, when you do homeworks in groups, you're very welcome and encouraged to exchange ideas, but what you write down has to come straight out of your understanding and onto the page. You can't, read someone else's work and copy. You also cannot read someone else's work and then, commit it to character by character memory and then write it down from memory. That's still copying, right? So you can look at other people's work for comprehension purposes, but then once you get it, it needs to come out in your own words. And that if it's coming out exactly the same as what someone else did, then you're not really doing that. So anyway, all right. Let me talk about expectations of you in this course. Everybody knows that in a math class there's going to be formulas to memorize. Everyone knows that in a math class there's going to be algorithms to execute, and you have to know how to execute those algorithms, and you have to know what those corresponding memorized formulas are. So, well, of course, that's a given. What is not uniformly the case in high school math classes is really understanding what these things are. Right? Very often, high school math classes kind of let that slide. Students can get away with kind of memorizing their way through the course, and not really get that understanding. So we're going to be testing explicitly understanding beyond things that you've memorized and algorithms that you've rehearsed. Right? So fair warning, I'm telling you right now, I'm going to ask you to explain things that you understand, and you're going to have to communicate those ideas in writing on the exams. Thirdly, and kind of related, again, fair warning, right? On the test, I'm going to ask you questions to which I have not previously told you the answers, right? So, I don't know about y'all's high school calculus classes, but so we, in my high school calculus class, there was they covered this idea of if you have a spherical, dome water tank and it's suspended a certain distance above the ground, how much work does it take to pump water into that tank? And the example's done out in great detail, and on the exam, it's a spherical water tank that with a slightly different radius, right? And maybe it's elevated higher or something, right? But so the numbers are different, but structurally it's exact same as an example that was worked out in full in class. So not going to be the case here, right? I'm going to give you literally unfamiliar situations. Sometimes, there will be some familiarity, but it'll be on the surface as much as completely different seeming examples. And here's the idea: the way you're going to solve these problems is you're going to use this understanding that you have. So specifically, these will be unfamiliar situations that are susceptible to the same techniques. Right? So you're going to take that understanding you have of the techniques and you're going to think through, well, how do the techniques used from other examples, I guess I got to tweak them in the following ways, but pretty much the same strategy, and here's the answer. Right. Okay, so that's what we're looking for. These are the three big things. Now, everything else that's on the page here is pretty much just saying the same thing, but it kind of in different ways and with different sort of points of view. I'd like to point out why it's not enough to just memorize certain algorithms and rehearse certain rehearse certain algorithms and memorize certain facts. And the answer that I like to point to is Wolfram Alpha. I think a lot of y'all probably know about Wolfram Alpha. Show of hands, just out of curiosity. Wolfram Alpha. Yeah, cool. So those of you who have not seen it before, Wolfram Alpha, it's a free thing on the internet. I think there is a subscription if you want certain additional benefits. But you can type in just kind of street language, something like that, integral of x times sine of x squared. I'm not using any fancy notation there or anything. And it will interpret and give me the answer. Right? And draw a picture. I didn't ask it to do that. Okay, so let's think about, now of course this is a class in linear algebra and differential equations. This problem is a single variable calculus problem. But just from that single variable calculus point of view, let's suppose that your proficiency with single variable calculus was that you're really good at doing integration by parts and substitutions and, turn the crank on anti-differentiation, symbolic manipulation, anti-differentiation. Well, if that's your main thing, right, then, okay, so you can do stuff that I can do for free on the internet. Except this is more reliable, faster, costs nothing. Right? So the question comes up, how much value does that really have to be able to do stuff like, turning the crank on integration by parts? Well, it does have some value to your ability to then go on to higher levels of math, right? There's certain kinds of differential equations that you can't solve at all without being able to do certain bits of anti-differentiation. So it's something you need to know. But the point is that that's it. If that's all you have, then it's like being really good at arithmetic or something. Yeah, which had value 75 years ago, but now with computers just all over the place, right? Being really, really, really good at arithmetic is not worth anything to speak of. So that's an important point to keep in mind. That's why we don't just teach algorithms and formulas, right? We need you to be able to do stuff that Wolfram Alpha can't do already for free, right? And what Wolfram Alpha cannot do is understand anything, of course, nor can it solve problems that it has not been specifically coded to solve. Right? So that's, your understanding of calculus in terms of, well, I understand that Riemann sums very naturally, as a structure, can be overlaid over lots of different kinds of applications, and I can, take this one idea, but I can apply it in lots of different ways, and therefore I can solve all of these problems. Wolfram Alpha does not get that. Wolfram Alpha cannot do that. Right? That's what makes you valuable when you're, let's say, on the job market or something like that, is the actual comprehension. Okay, is everybody on board? Does anybody have any questions about that? Okay. Related. Okay, so look, I'm going to be a mechanical engineer. Just show me what I need to know to be a mechanical engineer. I mean, what math techniques are going to come up when I get a job as a mechanical engineer? Come on, there's got to be a finite list. Just show me how to do those problems. Right? So, answer, I don't know what those are going to be. I don't know what the field of mechanical engineering is going to be dealing with. I don't know what field of mechanical engineering subfield you're going to go into, right? And the whole field is going to be totally different in like 10 years, right? So there is no such thing. You can't just learn specific things that you need to know. You need to understand general ideas so that when you get to the unknown, yet to be determined future, you'll be kind of ready for anything. That's the big idea. Okay. All right, so along these lines, on exams, we're looking for your understanding of ideas. We're looking for you to not only show your work, but have a process that is legitimate and thorough and appropriate to the context of the problem. We're looking for clarity of thought. We're looking for clarity of communication. If you really understand ideas, you can communicate them clearly. Awkward communication tends to kind of correlate with awkward understanding. So these are what we're going to be grading based on, right? Again, full warning, telling you right here. We're not just going to be looking at the number at the end in a box at the bottom of the page. That's negligible. I mean, it's nice if you get the right numerical answer, but we would much, much rather see an answer that's wildly wrong due to a sign error where all the ideas were good. Right? Really, everything was fine, clear communication. Sign error, you get a dramatically wrong answer. That's great. That's 9 out of 10. Maybe 10 out of 10, right? On the other hand, bad ideas, incomplete process, and just an amazing coincidence of, well, all these errors all just kind of canceled each other, and coincidentally the student got the right answer. Right? That's not good. So that's not going to be a good score at all. So make sure to give us this. Give us what we want. We will give you what you want. Right? We'll give you points in return for give us clarity of thought and thorough answers. Okay. All right. I wish I had more time. We are out of time. Oh golly. Real quick, make sure to understand, comprehension is not a yes or no thing, right? Comprehension is a spectrum. And make sure that, you're not in some sort of a mindset where you understand up to the level where you feel comfortable like you were in a high school math class and then you stop learning. Because Duke's bar is up here, right? Math 216 anyway. By the way, Math 216's bar is higher than Math 212, which was higher than Math 122L. Which is higher than high school, right? So the bar keeps going up, and you've got to make sure to learn up to that correspondingly high level. Okay, super quick. We've already talked about the video recordings. Attendance will count for the class, but it's not going to start until after drop ad and stuff like that. So we'll talk about that later. And if you would like to find people to study with, again, which I strongly encourage, if you don't already know a group of people that you think would be a good study group, send me an email. I will add you to a list. Only the people that are on the list looking for study groups will get your contact information and will therefore be contacting you. So it's sort of a confidential-ish way to find study groups. Okay. Now, last thing we're going to do, we have 4 minutes left. Last thing we're going to do is the quiz. So this is the first quiz. You all have already watched the pre-lecture. This quiz question is about the checkerboard problem. Right? And we're going to have a quiz every day. The purpose of this quiz is to make sure that everybody kind of sees how those procedures work. And let's see, let me switch over to the camera. If you go into your Sakai, there will be a tests and quizzes section of Sakai. Go into there and click on the quiz that says today's date. I think it says 2019-08-26. So that'll take you into that quiz. Don't submit your answer until you see the question. The question will be here on the screen. The question will not be in Sakai, so you can't do it remotely. Right? You got to come to class to get access to the quiz. Here is the question. Be careful when you submit your answer. You can only submit one time. You cannot submit and then, I forgot to such and such, and then submit again. You only get one submission. So think it through. We've got almost 3 minutes left. All right? And let me go ahead and reveal one other thing. Today's quiz is not going to count for your grade. I don't want anybody to freak out today, right? This is a kind of a practice, procedural sort of sanity check, right? But I do want everybody to submit an answer, to think it through, right? But again, mainly I wanted everyone to see how the quizzes are going to work, and I wanted everybody to see how the quiz questions are not going to be trivial. It's not going to be something that if you just kind of had the video on and half paid attention to it, that, of course, you immediately know the answer, right? This is a challenging, thoughtful problem. And the rest of the quizzes will also be. So you're not just supposed to watch the videos, you're supposed to study the videos. You got about 1.5 minutes left. That's just for if you want to see how those quizzes work, and if you want to submit an answer and see how does it show up in your grade book, or that's all that's for. Okay. Yeah, right. You got 1 minute left. One other super quick thing. Typically, the quizzes that like this one will be at the very start of class. We did it at the end of class today because the first day is always weird. But it'll always be in the first 5 minutes of class, so make sure you're on time. There won't be extra time if you show up late. About 30 seconds. Okay, about 10 seconds left. If you're done, you can take off. See you Wednesday. Oh, hey, let me kill the recording here. Sorry.